Okay, so here is the state transition diagram which I have drawn using the word itself. So as you can see, this is the one we draw already, and then we go to the complete state transition diagram for our circuit. You can double check whether we did correct, and these are the groups we made. I think it's also fine. So yeah, here it's QA. Okay, so not just A, but it's fine, you understand it. Then this is my simulation output, so you can try it as well. So let me explain what it does. Okay, so here I have clock, right? So there's the original clock, and I have made the signal a little bit slower using a secondary clock, and there is a reset signal as well. Does not matter. But after that, I have input signal. So now I'm checking uh, subsequent clock signals, right? So I have increased my input from one clock signal to two clock signal to three clock signals, uh, so that I see only I need to detect like subsequent ones, right? So here I don't have three subsequent ones. Here also I don't have three subsequent ones. Here I have, right? So let's see whether it is represented in our output. So Q naught and Q1 are our JK flip-flops output, and we have F here, which is our QA and QB, right? Now QA and QB is 1 at this scenario, right? Which means we have three different or three subsequent ones available here. Okay, four subsequent ones is again detected here. After three, it will continue to having the four as well, right? Here again, five subsequent ones, again it will detect uh, from 3 onwards, right? So you can see the state transitions, how it happens, right? You can go from, I mean, if it is 0, uh, 0 0, right? Q will be 0 0. So it's the 0th state. Then there is one time interval, uh, input signal is 1. Then our state transition table will go to 1 here. Okay, so my order is a little bit different here, but don't worry. This is 1, then here it is 1 2, right? The first one it will have 1, then at the second continuous or subsequent one it will be 2, right? Here again go back to 0 when you have 0 here, it will go back to state 0, then state 1 2 3, right? It will count to 3. Here 1 2 3, then remain in the state 3, right? Here also 1 2 3, remain in the state 3. As you can see, it is the signal detector which we needed. Okay, so I hope you learned it and enjoyed it, and yeah, practice and make sure you know the procedure. But one thing to say is that modern software programs like Xilinx actually can do this automatically, right? As you can see, this is just a procedure, right? Well defined procedure which anybody can follow. So the computer can also follow this same procedure to design any circuit. So you can actually determine only the behavior of your circuit, or you can input the state transition diagram or state transition table. You can represent this in a table and give it to the Xilinx in order to synthesize the circuit for us. Okay, so that's very easy to do, but this is for your learning purpose as beginners. So even though the software can do that for you, you need to know what is happening underneath, right? So that's the entire task of learning to solve these problems. Okay, so I hope you learned something and enjoyed it, and thank you.